about rational functions and asymptotes and wholes. So first of all, a rational function or equation are just fractional ones where there's usually a polynomial as a numerator and a different polynomial as the denominator. So my example there is f of x equals x minus 2 over x cubed minus 9x. Notice the degree of the numerator is 1. The degree of the denominator is 3. That's not important today, but I just thought I'd throw it out there. Okay, so when the numerator is equal to 0, that's where you get your x-intercepts, where the numerator is equal to 0. Okay, because if the numerator is 0, the whole thing is 0, which makes y equal to 0, and that's the x-axis. So that's not the focus today either, but I thought I'd throw that out there. All right, our focus today, are wholes and asymptotes. All right, when the denominator is 0, then your function could either have a whole or an asymptote, depending on what's going on. So here's an example. F of x equals x minus 3 over x cubed minus 9x. So the first thing you do is factor. You factor both the numerator and the denominator. So I've already did this. So notice x minus 3 on top doesn't get to change. The denominator, I factored out an x first, and then I have x squared minus 9, which I can factor as x minus 3x plus 3. So here's my function right here. This is the important thing right here, is this, okay? So now you're going to look at those factors and ask yourself, can I cancel anything before I get started? Because it's always nice to work with something smaller. If you can cancel factors, that's where you're going to find your wholes, okay? So notice I have x minus 3 in both the numerator and the denominator. So at x minus 3, which is equals 0, that's where you're going to find the whole, or at x equals 3. Okay, there's a whole. Now you're not going to see that whole because it only happens when x is exactly 3. Not 3.1, not 2.999, none of those has to be exactly 3. So you might not see the whole on your calculator, but if you go to your list of values, you will certainly see that it says error. All right, so asymptotes are where the remaining factors are of the denominator. Now it's very important, we only care about the denominator for asymptotes, where the denominator, those factors, equals 0. And so I notice I have x and I have an x plus 3. So when x equals 0, or when x plus 3 equals 0, or x equals negative 3, that's where I get my asymptotes. And asymptotes are vertical lines, and the graph is going to approach the asymptote, but it's not likely to cross. So I did a graph on Desmos, and I was able to capture, and let me just tell you, this took like 14 tries, the whole at 3. Notice in Desmos it's got a little hole there, and it says 3 undefined. So I was able to snag that image. So I thought that was kind of cool. And then I drew in the x equals 0 vertical line and the x equals negative 3 vertical line. And notice my graph is not touching. It's getting close to, but it doesn't touch. So those are my asymptotes. So I have vertical asymptotes. We'll talk about horizontal asymptotes another video, but we have vertical asymptotes there. Now, you may say, well, I can do this, but remember, not every rational function has wholes or asymptotes. It might have wholes, it might have asymptotes, it might have both, it might have neither. So here's an example that has neither wholes or asymptotes. Okay, so notice I cannot factor x squared plus 4, can I? No, because it's the sum of two squares. Well, I can if I use imaginary, but that's all done and over with. So no factoring. So that means no place does my denominator equals 0. So my domain is all reals. So notice where the numerator is 0, that's where it crosses the x-axis. And this numerator, x minus 2, that's going to be 0 at 2. And notice right here, at x equals 2, that's where it crossed the x-axis. But notice, no holes, no asymptotes. Okay? And here's the last example. I didn't write it all out, so we can kind of do it real quick together. F of x equals x squared minus 4x over x squared minus x. If you want to stop the video and then, do this stuff ahead of time. So the first thing we do is we factor numerator and denominator. So the numerator, I noticed, has an x in both of them, so x minus 4. And in the denominator, I noticed there's an x and then an x minus 1. So that's the first step. Oh, I should have done that in red. Oh, I could change that real quick, but I'm not going to. I'm going to write in blue now. So which factors cancel? Well, it looks like to me that the x and the x cancel. So when x equals 0, that's going to be a hole at x equals 0 because the x cancels. So now I will change to pink. So now which ones don't cancel? X minus 4 over x minus 1. So that means at x minus 1, which is the denominator, that's where my asymptote's going to be, my vertical asymptote. So add 1 to both sides, so x equals 1 is a vertical asymptote. Vertical asymptote. Now, that's a lot of irritating to write, so from now on I may just do VA for vertical asymptote, HA for horizontal asymptote, which we'll talk about in another video. Okay? So, there you go. Holes, they cancel, and asymptotes, they don't cancel. So just FYI, let me just real quick, if I asked you what the domain was, the domain, though, would be all reals except 0 and 1, because that's where my holes and asymptotes are. And then if I wanted to write that in interval form, negative infinity to 0, and then 0 to 1, and then 1 to positive infinity. All right, good luck.